hinge upon your understanding of what the heck they're even asking. Okay. In a work problem, there is one definition or vocabulary phrase that you need to know, and that is called work rate. I've got it in bold up here at the top. Okay, so I want you, the first thing you write down for me today is the phrase work rate. And you need to note that the work rate is simply the amount of the job that the person or the thing, whatever we're looking at, gets done in 1 unit of time. Okay, so this says a gardener can mow a golf course in 4 hours. Okay, how much of that job does he get done in 1 hour? Then would be his work rate. Okay, he gets a quarter of the job done in 1 hour. It's very straightforward to find the work rate. Okay, typically you'll just divide 1 over how long it takes them to do the job. If I can paint this classroom, right, in 7 hours, then I get 1/7 of the job done each hour. I get 1/7 and then 2/7 and then 3/7 and then 4/7 dot dot dot. And then after 7 hours, I've gotten 7/7 of the job done. I've finished the whole job. That makes sense? So work rate is the amount of the job completed in 1 unit at a time. So for our little problem right here, look at the chart that I've got set up. And at the top of this chart, right, we've still got rate times quantity equals total. All right. Obviously, work rate is rate. The time spent working is our quantity. And the amount of the job that gets completed is our total. So what this section's all about, like with work problems, fellas, is it's like teamwork, okay? So like, let's say I get Cash in here to help me. You know, is it going to take the two of us the full 7 hours to paint the room? No, because I can paint it by myself in 7 hours. Let's say Cash can paint it by himself in 6 hours. The two of us working together are going to be able to complete it much quicker, right? Because we're teaming up. That's how a work rate problem goes, okay? Now, I would encourage you to go ahead and fill out the info that you can in the charts. The first gardener's work rate we said was 1/4. And it says that another gardener can mow the same golf course in 6 hours. All right. So, Colton, what would his work rate be? Very good. 1/6. Now, the question that they're asking is how long will it take the two gardeners together to mow the course? So, we don't know their time. That's going to be our unknown. Okay. That's going to be our unknown. And then we simply multiply from left to right, as we always do. Whether it's a dirt problem, whether it's coins and the number of coins, the value per coin, and total amount of money, we always multiply from left to right. William.
Wouldn't the time working be 4 hours and 6 hours though? Because they give it to us in the.
Great question. Short answer, no. Okay. The 4 hours and the 6 hours, listen to me on this, folks. The 4 hours and the 6 hours is a hypothetical scenario if they were working on their own. It would take them 4 hours to do the whole room, or in this case, to mow the whole course, okay? The 6 hours would be if that gardener number 2 was working by himself the whole time. So now that they're working together, right, it says how long will it take them working together? That's going to be less than the 4 hours and the 6 hours, right? Because they're tag teaming it. Which one works faster, by the way? Yeah, the first gardener. So like if I were to draw a big old picture, I know golf courses don't look like this, but let's pretend like that's the golf course, right? You could probably say, like, here's where gardener number 1 would complete all that grass cutting, and gardener number 2 would complete a little bit less because he's not working as fast, right? But they complete the whole amount of the golf course. Well, you know what? The amount that is completed is going to show up in this box. The amount that's completed by the second gardener is going to show up in this box. And then note what we say down here in red, that we add the two amounts together to equal one whole golf course. Nick. You know, that's a great question. Oftentimes it will be the same when the two people are working together. Now, there was a rule when I was growing up, okay? And I don't know if you guys help your mom or your dad when you're doing work outside. Does anybody work out in the yard? You guys have to do yard work? Okay. That's a great thing for a kid to do, right? Teddy Morgan gets out in the yard and he helps me when I'm working, pulling weeds, picking up sticks, cutting down trees. He helps. The girls, they like to rake leaves. They help their mama plant plants. Working out in the yard is a good thing. When I was a kid, we had a rule that you don't go in until dad goes in, okay? You're not allowed to go in until dad goes in. So if we're working and the dadgum sun has set and dad's still out there working, guess what? Mr. Morgan and his brother are still out there working, okay? But there's once in a while where he would call me and he would say, hey, boy, you and your brother get outside. Y'all start working. I put a trailer full of mulch in the yard, right? I want that trailer empty by the time I get home. And then we're going to continue to work some more. So like me and my brother, we might work like for an hour before Dad got home. And then we'd stay out till Dad finished. So were the times equal in that scenario? No. Jason and Sean would work, let's say, X plus 1. If Dad worked X, Jason and Sean would work X plus 1. Okay? Our times wouldn't be the same in that case. But we could still express them using a similar variable. In this scenario, in this problem, the gardeners' times, they're both X because they both start at the same time and they both end at the same time. Okay? You'll see scenarios once in a while, though, where the times are different. Great question, Nick Pache. Somebody else. I feel like somebody else had a hand up. Right? No? All right. So we multiply from left to right. Hogan, help me with that top box. What's 1/4 times X going to yield? Yeah, very good. And I'm going to actually write this as X over 4, just personal preference. And then down at the bottom, it's going to be X over 6. And what we're going to do now is we're going to combine those two. Here's how we're going to write up our equation. We're going to say X over 4 plus X over 6 equals 1 whole job. It says this column should sum up to the amount of the job completed together. That problem said, how long will it take the two gardeners' work to mow the whole golf course? Okay, we set it equal to 1. If they had said, how long will it take these two gardeners to mow half the golf course, we'd set it equal to a half. Okay, that's just plain and simple. If it said, how long would it take them to mow this golf course and a similar golf course next door, right? You'd say, oh, well, we're going to have to set it equal to 2 because they're doing 2 of those jobs, as described in the problem. But 9 times out of 10, fellas, you're just going to add it up, set it equal to 1. That's how a work problem goes. Okay. Now, what type of equation is that up there in red? Very good. That's a rational equation, okay? Santiago, do you remember how I prefer solving rational equations? Kill the fractions. That's right. And Luke, tell us what we do. Luke, tell us what we use to kill those fractions. Luke starts with an L. And so what do I do to kill those fractions? My hint was to no avail. Joseph Russell, help him out. Use the LCD. Luke won't forget that again because it starts with L just like Luke does. So we use the LCD, Jacob Alpern. What is the LCD? Try again. 12, good. Now 24 will get the job done, but it's not the LCD. So I'd have an extra step at the end, which I like to try to avoid if I can. So I'm going to multiply everything by 12. So I'm going to multiply this by 12 and that by 12, right? How dare you? Good, 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 good. You didn't fall for my trap, did you? Whoops, I'm thinking 24 from what Alpern said, dadgummit. Hold on. There we go. All right, so whatever I do on the left, I do on the right. It's going to kill those fractions, as I think Santiago said. So 12 over 4 is going to leave me with a 3 and an X. Remember, I asked you the question, what cancels out and what's left over? Bless you. So 12 over 6 is going to leave me with a 2, and then there's an X up top. And then, of course, over here we got 12. So we got 5x equals 12, and then x equals 12 fifths. Now, it would not make sense for me to say, hey, Justin, it took these guys 12 fifths of an hour to mow the golf course. I should probably go ahead and say, 2 hours and 24 minutes. All right, that would make more sense. So 2 hours and 24 minutes is a more easily understood way of expressing time than saying, hey, 12 fifths of an hour. Okay. How did I do 2 hours and 24 minutes so quickly in my head? What do you think, William Bryan? So I haven't done this problem in a year, okay? But I did do what William said. 12 divided by 5 is 2, so there's 2 whole numbers, right? A mixed number has a whole number and a remainder. The remainder of 2 fifths, I have memorized that 1/5 of an hour is how many minutes? 12 minutes. That's a great fact, by the way, to commit to memory. Did you know that? That 1/5 of an hour is 12 minutes. What's 1/12 of an hour? 5 minutes, okay? Because 12 times 5 is? 12 times 5 is 60, okay? Good little factoid to have memorized, right? And so anywho, if I got 2/5 as a remainder, I know that's 24 minutes, and that makes a good, easy conversion there. If needs be, how else could we convert from hours into minutes? Like if I said 0.7 hours, and I wanted you to convert that into minutes, what could you do? Not move the decimal. Not divide by 60, multiply by 60. Good. So you'd say 60 times that, and you'd get 7 times 0 is 0, 7 times 6 is 42, and you got 42 minutes is 1/7 of an hour. Excuse me, 7/10 of an hour, pardon me. All right. So that kind of little skill right there, that's a good skill to have too. A little basic conversion rate. All right, so we've answered our question here. It took them 2 hours, 24 minutes. Any questions on the work rate or how the work problem figured out? Okay. Now, you guys are in an honors math class, so I feel like it's my duty and it's your privilege to deal with curveballs every now and then. Okay. One type of curveball that you might encounter is when two things are working against one another. Okay. And I'm not saying that you could possibly do that in this scenario, right? How could somebody uncut the grass, you know? All right. But, you know, my daughter, Betsy, likes to take a bath. Okay. Do I have any bath takers in the house? Anybody like to take a good hot bath?
Depends on what mood I'm in.
Okay. I hear you. We got a little bathtub in my bathroom that has like these jacuzzi, whirlpool jet kind of thingies. And so she really likes it when we put some bubble bath in there and turn those on. She loves a bath bomb. Y'all know what a bath bomb is? Right. Oh, that explains everything. You don't eat the bath bomb, Luke. Hey, anywho, so like imagine a bathtub, and I tell Betsy to go fill the bathtub up, and so she turns the spigots on, but she forgets to put the drain in. That's a scenario where two things are working against each other, aren't they? Right? The drain is working to drain the tub, while the faucet is working to fill the tub. Okay? So in that scenario, you would not use addition. You would use subtraction. How now, brown cow? Okay? And so that's where a little curveball, a little deuce piece could come your way, okay? So if they're working against each other, don't add them together. Use subtraction, okay? Let's see. I think I got one for y'all to practice on your own, though. No curveball here, just plain old work problem. And I give you a hint here because this one doesn't ask how long it's going to take for them to work together. This one says how long does it take for this person, his sister, how long does it take his sister to clean the house by herself? So I give you a hint in your chart. Once you let 1/x be the sister's work rate, since x is going to answer my question, how long it takes her by herself. Okay, set you up a chart and see if you can knock this one out. Little work rate problem. Rashawn? Yeah. Yes, I can. Boy, the MUS last night had a kid named Rashawn. Arshawn. And he spelled it differently. It was like R apostrophe and then CHAUN. He's a freshman. He's y'all's age. Dude, he is built like a brick house. That kid is giant. He was I think he was 6'5", and he probably looked like about 230. Yeah. He was pretty swole. He's pretty swole. I think Quinn Page could take him though. I'm in a basketball game. Why you gotta be so violent, Luke?
Quinn would run between his legs. Is he a camera on?
Yeah, he heard me.
Is he a Corona?
It's none of your business.
Kinda. I guess then I'd have to quit.
Yeah, he's sitting on his desk. He was sitting on. Yeah.
You shouldn't be sitting on somebody's desk. I spray that desk down 6 times a day though, so it's all good. Make you a chart, fellas. Make you a chart. You can do these without them, but I think the chart's super helpful. All right, I'm going to quietly, you might still be working and that's A-okay. I'm going to quietly set my chart up. Okay. So I got my chart set up. I got my equation written. Remember your 5-step word problem solving method. Figure out what they're asking, assign a variable, write an equation, solve an equation, answer a question. We've now done 3 steps with the chart and the equation. Okay. So figured out, once the equation gets figured out, the mechanics of solving it should be pretty rapid. Okay. Jackson, did you get the same equation? Okay. Considering this equation, and we can talk about why you didn't get this equation in just a second, but considering what I've got in blue up there, what would you do to both sides? Oh, we don't want to divide by 3. I'll throw it back to Luke, since I asked Luke this question earlier. What do I do, Luke, to kill all these fractions? Multiply by the LCD. Now, Jackson, I'll put it back your way. What's the LCD from this equation? 7x. Good. So I'm going to put 7x on the top of every fraction and over on the right-hand side. In other words, I'm going to do 7x times the left, 7x times the right. Now, here's where I'm going to push you a little bit. I've been pushing you guys, okay? I want you to do that, answer my 2 questions in your head, okay? What cancels, what is left? I want you to do that in your head. So we'll put on what cancels on the first fraction. What's left? Good. Okay. Justin, what cancels in the middle fraction? Good. What's left? Not 3 over 7. We're multiplying the top. So good. We got 21. And then over on the right-hand side, nothing cancels because there was no fractions. We just got 7x. All right. So Ryan Jeffers, take me home. What do I do?
Subtract 3x from both sides.
Then?
And then divide by 4.
Perfect. So 21 divided by 4 divided by 4. We got x equals 21 fourths. Now, again, it wouldn't make sense for me to say, hey, JT, I'll be at your house in 21 fourths of an hour. You know, that's crazy talk. You'd look at me like I was nutso. But if we divide 21 by 4 and we get 5 1/4, that makes more sense. 5 1/4 hours or 5 hours and 15 minutes. You know what I'm saying, fellas? Give an answer that makes common sense. All right, so cleaning the house by herself, she's a little faster than her brother is. It would take her 5 hours, 15 minutes. To do what? To clean? Man, I tell you what though, if you're cleaning a house, like you're scrubbing bathrooms and you're washing windows and you're vacuuming and dusting and doing laundry.
I just leave that up to my.
Do what?
I just leave that up to my mom.
You're that kid. Okay.
I don't
Poor,
do heavy labor.
poor Sylvia. My goodness. Mrs. Morgan, I'm bad about cleaning bathrooms. Mrs. Morgan is the bathroom cleaner in my house. She always does a great job of cleaning our bathrooms, and I like to consider myself a good husband. So I take care of other things like washing dishes and cooking dinner a lot of times, and doing all the outside like cutting grass and all that stuff. But she's always doing those. I hate bathrooms. I just don't want to clean a stinky toilet.
My mom's kind of a home mom.
Oh man, my mother stayed at home. My mom keeps an immaculate house. So when I was a kid growing up, she was a stay-at-home mom, and I always just thought, mom, you got a cushy life. You're a stay-at-home mom or whatever. And now that I'm an adult, number one, I'm like, man, what a blessing that was. If you got anybody else have a stay-at-home mom? Okay, if you got a stay-at-home mom, that is a big blessing because bozos like me, I can't afford for Mrs. Morgan to be a stay-at-home mom. She works a job to help pay the bills. But then second of all, it's freaking hard work being a stay-at-home mom. I mean, you're every day. If you're doing it right, it ain't like you're sitting on the couch eating bonbons, watching TV all day. You're working to keep that household straight. So y'all give your mama some credit, definitely. Any questions on that? By the way, I know Jackson, you had said you didn't get the same equation. Did you figure out what you did wrong? Okay. Any questions on the work problems? It's one small little microcosm of these word problems. The next kind of word problem we're going to talk about is variation problems. Okay, variation. So let me zoom out since I had zoomed in on the last one. And you guys need to write down variation problems come in a couple of different varieties. No pun intended here. You will learn more about this in Algebra 2 with either Mr. Coach Dollar or Mrs. McConnell. But when we talk about variation, okay, variation can be direct, can be inverse, can be joint, or can be combined. Write those four phrases down. All right. So variation, there's four types that you'll learn about. There's direct variation, there's inverse variation, there's joint variation, and there's combined variation. Okay? The first two you and I get to talk about, and then the last two you'll discuss in your Algebra 2 classes. So we're going to talk about direct and inverse variations today. Joint variation and combined variation. And I'll kind of allude to both of those informally here. But hey, look, direct variation is very simple. If two things vary directly, what that means is that if one goes up, the other goes up. If one goes down, the other goes down. Okay? So like I'll use myself as an example. All right? The more time I spend in the weight room, the stronger I get. All right? That's a direct correlation, a direct variation. Okay? That means if I spend 2 hours in the gym every week, okay, I've got this particular metric of strength. But if I spend 5 hours in the gym during my week, then my strength factor would be higher accordingly. Okay? So you can think in your own lives about direct variations. Okay? The more you put in, the more you get out. You can think about your bank account that way, right? Your savings account. You guys have savings accounts? Anybody? Okay. The more you put in, the more interest you earn. That's a direct relationship. It is based on a constant of variation. All right. Now we call a constant of variation a constant. I don't want to insult your intelligence, but that's because it does not change. Constant means fixed. Okay. So you think about your bank account, right? What would the constant be in that scenario? The rate of interest. Very good, Luke. So like your bank right now might pay you like 0.5 percentage point of interest for a savings account. Okay. No matter how much you put in, you might put in 100, you might put in 1,000, and in the same bank, you're getting the fixed constant there is the interest rate. Okay. Now there's a formula that we have that you need to write down. The direct variation formula looks just like this. It's y equals kx. And the way that we phrase that is we say that y varies directly as x, or y varies directly with x. So you ought to be able to translate. Listen to me. If you see a phrase in English that says, this varies directly with that, then you're going to say this equals K times that. All right, you translate from English into math. All right, so Coach Morgan's time in the weight room, or excuse me, Coach Morgan's strength varies directly as his time in the weight room. Okay, or Luke's bank account balance, the amount of interest that he earns varies directly as the amount of money that he invests. Okay, and then the way that we could find what our constant is to solve for K, we just divide both sides by X. So K equals Y over X, and it would equal Y over X for that first kid or that second kid or that third kid or whatever scenario you're talking about. It is constant. Okay, now what kind of function takes the form of Y equals KX? We've studied this kind of function this year already. What kind of function? It is a linear function. Write down that direct variation is a linear relationship. Okay? And again, not to insult anybody's intelligence, but what does a linear relationship look like? What's the shape? A line. Yeah, very good. Direct variation is a line. Okay? Direct variation is a linear relationship. Okay. Now, consider my two. Ooh, that was bad. Let me try this again. Still curved. What's wrong with my hand today? No, that's too far to the left. There we go. Can't draw a straight line today to save my life. Anywho, all right. So, like, consider. Let's say Luke is his bank account is modeled by the red line, and let's say that Wilson's bank account is the blue line, okay? All right. All things equal, right? Which one has a higher constant of proportionality? Which one has a higher constant of variation? The blue one does. Regarding those lines, what characteristic do we call that? It starts with an S. The slope. So make a note that the constant of variation, K, also known as our constant of proportionality, is the slope of the line. All right, your constant is the slope of the line. And then I got a little step-by-step approach. You guys are taking diligent notes over here today. I got a little step-by-step approach. Step 1, step 2, step 3. Jot those down quickly. This is how most folks will work direct variation problem. Okay. Trying to learn to like hot tea. It's not going so well. Tried 3 different kinds, and all 3 of them taste like butt.
You like chamomile?
I haven't tried chamomile.
I like that one a lot. It's like the most attraction.
So Luke likes one, chamomile, and Cash says that's trash. Luke. Cash says chamomile is for sissies.
It gets you to go to sleep.
William, right?
It's true.
Okay. Well, I'm just trying to find an alternative for hot chocolate. I love hot chocolate. That's my drink of choice during the winter months, especially to soothe my vocal cords and because when I get home every day, my voice is tired from teaching and yelling and talking and doing all kinds of vocal stuff all day. So I need to soothe it. But drinking hot chocolate all the time, I can't have that much sugar. It's making my health plummet. I don't want to be consuming cups and cups and cups of sugary sweets.
Have you ever considered coffee?
So I've tried coffee before. Yeah, Mrs. Morgan's a big coffee drinker, and I don't like the taste of it. It's too bitter. But that's how I feel about this tea right now. It's just bitter.
Put some cream.
Well, cream ain't daggum healthy for you. Milk and sugar and all that stuff.
Hot tea isn't like necessarily healthy either.
You know, there's this episode of The Office where Michael Scott starts his own paper company, this series of episodes. And so he goes to pick up Pam to make some deliveries, and she's like, "Oh, is that coffee?" He's like, "Milk and sugar." And she's like, "Sweet, thank you so much." And she drinks it, and it's just milk and sugar. It's not coffee. It's milk with sugar in it. And she's like, "You drink this?
That sounds kind of good.
Milk and sugar? Ew."
You drink milk raw? What kind of monster are you?
What kind of adulterations do you put in your milk there, Luke?
I don't drink just raw milk because I'm not an animal.
Hey, chocolate milk's a good recovery drink.
I'll pop a chocolate milk when I'm
Hey, you know what? We will. I think I've got about a minute left with you guys, so we'll pick up with this example. What is this, example 8? I'll put together a little screencast for you guys to watch tomorrow. We'll do examples 8 and 9. It'll be a short screencast, so watch it. And then, hey, look, tomorrow when you're in class, I want you guys working on your ACT practice quiz. It is a quiz this week, right? Remember? And then I also want you working on your handwritten homework. The handwritten homework will be due on Friday, okay? On Friday. So, hey, I'm going to cut you guys loose. You guys at home, y'all have a great day. Everybody live Jesus in our hearts. Thank you so much. And wait till the bell rings before you get up and start walking around. This is a controversial opinion that you have.